The Focke-Wulf Fw 190 1/4 was a German single-seat, single-engine fighter aircraft designed by Kurt Tank in the late 1930s and widely used during World War II. Powered by a radial engine in most versions, the Fw 190 had ample power and was able to lift larger loads than its well-known counterpart, the Messerschmitt Bf 109. The Fw 190 was used by the Luftwaffe in a wide variety of roles, including day fighter, fighter bomber, ground attack aircraft and, to a lesser degree, night fighter. When the Fw 190 started flying operationally over France in August 1941, it quickly proved itself to be superior in orbit turn radius to the Royal Air Force's main frontline fighter, the Spitfire Mk, especially at low and medium altitudes. The 190 maintained superiority over Allied fighters until the introduction of the improved Spitfire Mk. 9 in July 1942 restored qualitative parity. The Fw 190 made its air combat debut on the Eastern Front in November-December 1942. Though Soviet pilots considered the Bf 109 a greater threat, the Fw 190 made a significant impact. The fighter and its pilots proved just as capable as the Bf 109 in aerial combat, and in the opinion of German pilots who flew both, provided increased firepower and maneuverability at low to medium altitude. The Fw 190 became the backbone of the Jagdwaffe, along with the Bf 109. On the Eastern Front, the Fw 190 was versatile enough to use in Schlechtgeschwader, specialized ground attack units which achieved much success against Soviet ground forces. As an interceptor, the Fw 190 underwent improvements to make it effective at high altitude, enabling it to maintain relative parity with its Allied opponents. The Fw 190A series performance decreased at high altitudes and above, which reduced its effectiveness as a high-altitude interceptor, but this problem was mostly rectified in later models, particularly in the Junkers Jumo 213 inline-engine Focke-Wulf Fw 190D series, which was introduced in September 1944. In spite of his successes, it never entirely replaced the Bf 109. The Fw 190 was well liked by its pilots. Some of the Luftwaffe's most successful fighter aces claimed a great many of their kills while flying it, including Otto Kittel, Walter Nowotny and Erich Rudolph. Early development, Genesis. In autumn 1937, the German Ministry of Aviation asked various designers for a new fighter to fight alongside the Messerschmitt Bf 109, Germany's frontline fighter. Although the Bf 109 was an extremely competitive fighter, the Ministry of Aviation was worried that future foreign designs might outclass it, and wanted to have new aircraft under development to meet these possible challenges. Kurt Tank responded with a number of designs, most incorporating liquid-cooled inline engines. However, it was not until a design was presented using the air-cooled, 14-cylinder BMW 139 radial engine that the Ministry of Aviation's interest was aroused. As this design used a radial engine, it would not compete with the inline-powered Bf 109 for engines, when there were already too few Daimler-Benz DB601s to go around. This was not the case for competing advanced designs like the Heinkel He 100 or Focke-Wulf Fw 187, where production would compete with the 109 or Messerschmitt Bf 110 for engine supplies. After the war, Tank denied a rumor that he had to fight a battle with the ministry to convince them of the radial engine's merits. Design concepts. At the time, the use of radial engines in land-based fighters was relatively rare in Europe, as it was believed that their large frontal area would cause too much drag on something as small as a fighter. Tank was not convinced of this, having witnessed the successful use of radial engines by the U.S. Navy, and felt a properly streamlined installation would eliminate this problem. The hottest points on any air-cooled engine are the cylinder heads, located along the outside diameter of a radial engine. In order to provide sufficient air to cool the engine, airflow had to be maximized at this outer edge, which was normally accomplished by leaving the majority of the front face of the engine open to the air. During the late 1920s, NACA led development of a dramatic improvement by placing an airfoil-shaped ring around the outside of the cylinder heads. The shaping accelerated the air as it entered the front of the cowl, increasing the total airflow, and allowing the opening in front of the engine to be made smaller. Tank introduced a further refinement to this basic concept. He suggested placing most of the airflow components on the propeller, in the form of an oversized propeller spinner whose outside diameter was the same as the engine. The cowl around the engine proper was greatly simplified, essentially a basic cylinder. Air entered through a small hole at the center of the propeller, and was directed through ductwork in the spinner so it was blowing rearward along the cylinder heads. To provide enough airflow, a cone was placed in the center of the hole, over the propeller hub, which was intended to compress the airflow and allow a smaller opening to be used. In theory, the tight-fitting cowling also provided some thrust due to the compression and heating of air as it flowed through the cowling. As to the rest of the design philosophy, Tank wanted something more than an aircraft built only for speed. Tank outlined the reasoning. The Messerschmitt 109, SIC and the British Spitfire, the two fastest fighters in world at the time we began work on the Fw-190, could both be summed up as a very large engine on the front of the smallest possible airframe. In each case armament had been added almost as an afterthought. These designs, both of which admittedly proved successful, could be likened to racehorses. Given the right amount of pampering and easy course, they could outrun anything. But the moment the going became tough they were liable to falter. During World War I, I served in the cavalry and in the infantry. I had seen the harsh conditions under which military equipment had to work in wartime. I felt sure that a quite different breed of fighter would also have a place in any future conflict, one that could operate from ill-prepared frontline airfields. One that could be flown and maintained by men who had received only short training. And one that could absorb a reasonable amount of battle damage and still get back. This was the background thinking behind the Focke-Wulf 190. It was not to be a racehorse but a Dienstpferd, a cavalry horse. One of the main features of the Fw-190 was its wide-tracked, inwards retracting landing gear, designed to withstand a sink rate of 4.5 meters per second, double the strength factor usually required. Hydraulic wheel brakes were used. The wide-track landing gear produced better ground handling characteristics, and the Fw-190 suffered fewer ground accidents than the Bf-109 with its narrow track, outwards retracting landing gear hinged on its wing root structure. The retractable tail gear used a cable, which was guided over a set of pulleys located in the vertical fin, to pull the alleo strut upwards into the lower fuselage. On some versions of the Fw-190 an extended alleo strut could be fitted for larger-sized loads beneath the fuselage. Most aircraft of the era used cables and pulleys to operate their controls. The cables tended to stretch, resulting in the sensations of give and play that made the controls less crisp and responsive, and required constant maintenance to correct. For the new design, the team replaced the cables with rigid pushrods and bearings to eliminate this problem. Another innovation was making the controls as light as possible. The maximum resistance of the ailerons was limited to 8 lb as the average man's wrist could not exert a greater force. The empennage featured relatively small and well-balanced horizontal and vertical surfaces. The design team also attempted to minimize changes in the aircraft's trim at varying speeds, thus reducing the pilot's workload. They were so successful in this regard that they found in-flight adjustable aileron and rudder trim tabs were not necessary. Small, fixed tabs were fitted to control surfaces and adjusted for proper balance during initial test flights. Only the elevator trim needed to be adjusted in flight. This was accomplished by tilting the entire horizontal tail plane with an electric motor, with an angle of incidence ranging from -3° to +5°. Another aspect of the new design was the extensive use of electrically powered equipment instead of the hydraulic systems used by most aircraft manufacturers of the time. On the first two prototypes, the main landing gear was hydraulic. Starting with the third prototype, the undercarriage was operated by push buttons controlling electric motors in the wings, and was kept in position by electric up and down locks. The armament was also loaded and fired electrically. Tank believed that service use would prove that electrically powered systems were more reliable and more rugged than hydraulics, electric lines being much less prone to damage from enemy fire. As was the case for the 109, the 190 featured a fairly small wing plan form with relatively high wing loading. This presents a trade-off in performance. An aircraft with a smaller wing suffers less drag in most flight and therefore flies faster and may have better range. However, it also means the wing cannot generate extra lift as easily, which is needed for maneuvering or flight at high altitudes. The wing span 9.5 am and had an area of 15 m². The wing was designed using the NACA 23015.3 airfoil at the root and the NACA 23009 airfoil at the tip. Earlier designs generally featured canopies consisting of small plates of perspex in a metal framework, and the fuselage running horizontally back from the top of the canopy frame. This design considerably limited visibility, especially to the rear. The introduction of vacuum forming led to the creation of the bubble canopy, which was largely self-supporting, and could be mounted over the cockpit, offering greatly improved all-round views. Tank's new design included a canopy that used only a single perimeter frame with only a single short centerline seam frame forward of the radio antenna fitting atop the canopy's highest point where the three-panel windscreen and forward edge of the canopy met, just in front of the pilot. Variants. First prototypes. FW190V1, civil registration DOPZE, powered by a 1550 PS BMW 139 14-cylinder two-row radial engine, first flew on June 1, 1939. FW190V2, designated with the Stammkennzeichen alphabetic ID code of FL+, was the V2 first flew on October 31, 1939 and was equipped from the outset with a new spinner and cooling fan. It was armed with one Rheinmetall Borsig 7.92 MG-17 machine gun and one 13 synchronized MG-131 machine gun in each wing root. FW190V3, abandoned, FW190V4, abandoned, later prototypes. FW190V5, fitted with a larger, more powerful 14-cylinder two-row BMW 801 radial engine. This engine introduced a pioneering example of an engine management system called the commanded recurrency T, in effect, an electromechanical computer which set mixture, propeller pitch, boost, and magnetode timing. FW190V5K, clean Focke-Wulf Fw, small surface, the smaller span initial variant redesignated after the longer span wing was fitted. The V5 first flew in the early spring of 1940. The weight increase with all of the modifications was substantial, about 635 kg, leading to higher wing loading and a deterioration in handling. Plans were made to create a new wing with more area to address these issues. FW190V5G, Focke-Wulf Fw, large surface. In August 1940 a collision with a ground vehicle damaged the V5 and it was sent back to the factory for major repairs. This was an opportune time to rebuild it with a new wing which was less tapered in plan than the original design, extending the leading and trailing edges outward to increase the area. The new wing had an area of 18.30 m², and now spanned 10.506 am. After conversion, the aircraft was called the V5G for Focke-Wulf Fw. Although it was 10 km/h slower than when fitted with a small wing, V5G was much more maneuverable and had a faster climb rate. This new wing platform was to be used for all major production versions of the FW190. FW190A. FW190AO, the pre-production FW190AO series was ordered in November 1940, a total of 28 being completed. Because they were built before the new wing design was fully tested and approved, the first 9 A0s were fitted with the original small wings. All were armed with 6 7.92 MG-17 machine guns, -4 synchronized weapons, 2 in the forward fuselage and 1 in each wing root, supplemented by a free-firing MG-17 in each wing, outboard of the propeller disc. FW190A1, The FW190A1 was in production from June 1941. It was powered by the BMW 801C1 engine, rated at 1,560 PS for takeoff. Armament included two fuselage-mounted 7.92 mm G-17s and two wing root-mounted 7.92 mm G-17s and two outboard wing-mounted 20 mm GFF MIS. FW190A2. The introduction of the BMW 801C2 resulted in the FW190A2 model, first introduced in October 1941. The A2 wing weaponry was updated, with the two-wing root-mounted 7.92 mm G-17s being replaced by 20 mm G151/20E cannon. FW190A3. The FW190A3 was equipped with a BMW 801D2 engine, which increased power to 1,700 PS at takeoff. The A3 retained the same weaponry as the A2. FW190A3/U1 was the first 190 to have the engine mount extended by 15 cm, which would be standardized on the later production A5 model. FW190A3/U2. The A3/U2 had LZ-6573 on rocket launcher racks under the wings with 3 rockets per wing. There were also a small number of U-7 aircraft tested as high-altitude fighters armed with only two 20 mm G151 cannon, but with reduced overall weight. FW190A3/U3. The A3/U3 was the first of the JABO, using an etc. 501 centerline bomb rack able to carry up to 500 kg of bombs or, with horizontal stabilizing bars, one 300 drop tank. The U-3 retained the fuselage-mounted 7.92 mm G-17s and the wing-mounted 20 mm G151 cannon, with the outer MGFF being removed. FW190A3/U4. The A3/U4 was a reconnaissance version with two B12.5 cameras in the rear fuselage and a EK-16 gun camera or a Robot 2 miniature camera in the leading edge of the port wing root. Armament was similar to the U-3, however, and the etc. 501 was usually fitted with a 300 drop tank. FW190A3A, A equals all occurrence Indisch, foreign. In autumn 1942, 72 new aircraft were delivered to Turkey in an effort to keep that country friendly to the Axis powers. These were designated FW190A3A, designation for export models and delivered between October 1942 and March 1943. FW190A4, introduced in July 1942, the A4 was equipped with the same engine and basic armament as the A3. FW190A4 per Rankine 6, some A4s were fitted with a pair of underwing Würger Granite 21 rocket mortars, and were designated FW190A4 per Rankine 6. FW190A4/U1, the A4/U1 was outfitted with an etc. 501 rack under the fuselage. All armament except for the MG151 cannon was removed. FW190A4/U3, the A4/U3 was very similar to the U1, and later served as the prototype for the FW190F1 assault fighter. FW190A4/U4, the A4/U4 was a reconnaissance fighter, with two B12.4 cameras in the rear fuselage and an EK-16 or Robot 2 gun camera. The U-4 was equipped with fuselage-mounted 7.92 mm G-17s and 20 mm G151 cannon. FW190A4/U7, the A4/U7 was a high-altitude fighter, easily identified by the compressor air intakes on either side of the cowling. Adolf Galland flew a U-7 in the spring of 1943. FW190A4/U8. The A4/U8 was the JABO-A, adding a 300 drop tank under each wing, on VTR Ju-87 racks with duralumin fairings produced by Messerschmitt Bf, and a centerline bomb rack. The outer wing mounted 20 mm GFF cannon and the cowling mounted 7.92 mm G-17 were removed to save weight. The A4/U8 was the precursor of the FW190G1. Fw190A4 per Rankine 1, the A4 per Rankine 1, was fitted with a Focke-16ZY radio set with a marine whip aerial fitted under the port wing. These aircraft, called later Currencyger or fighter formation leaders, could be tracked and directed from the ground via specialty equipment called Würger. More frequent use of this equipment was made from the A5 onwards. Fw190A5, the A5 was developed after it was determined that the Fw190 could easily carry more ordnance. The D2 engine was moved forward another 15 cm as had been tried out earlier on the service test A3/U1 aircraft, moving the center of gravity forward to allow more weight to be carried aft. Fw190A5/U2, the A5/U2 was designed as a night jayberry and featured anti-reflective fittings and exhaust flame dampeners. A centerline etc. 501 rack typically held a 250 kg bomb, and wing-mounted racks mounted 300 AL drop tanks. A EK-16 gun camera, as well as landing lights, were fitted to the wing leading edge. The U-2 was armed with only two 20mm G151 cannon. Fw190A5/U3, the A5/U3 was a Jabo fighter fitted with etc. 501s for drop tanks and bombs. It too featured only two MG151s for armament. Fw190A5/U4, the A5/U4 was a recon fighter with two AB-12.5 cameras and all armament of the basic A5 with the exception of the MGFF cannon. Fw190A5/U8, the A5/U8 was another Jabo outfitted with SC-250 centerline mounted bombs, underwing 300-liter drop tanks and only two MG151s. It later became the Fw190G2. Fw190A5/U9, test installation of the A7 modifications. Fw190A5/U12, a special U-12 was created for bomber attack, outfitted with the standard 7.92mm G17 and 20mm G151 but replacing the outer wing 20mm GFF cannon with two underwing gun pods containing two 20mm G151/20 each, for a total of 2 machine guns and 6 cannon. Fw190A5 per Rankine 11, the A5 per Rankine 11 was a night fighter conversion fitted with Focke 217-ton radar equipment with arrays of 3 dipole antenna elements vertically mounted fore and aft to the cockpit and above and below the wings. Flame dampening boxes were fitted over the exhaust exits. 1,752 A5s were built from November 1942 to June 1943. Fw190A6, the A6 was developed to address shortcomings found in previous A models when attacking U.S. heavy bombers. A structurally redesigned and lighter wing was introduced and the normal armament was increased to 2 MG-17 fuselage machine guns and 4 20mm G151/20E wing root and outer wing cannon with larger ammunition boxes. Fw190A7, the A7 entered production in November 1943, equipped with a BMW 801D2 engine, again producing 1,700 PS and 2 fuselage-mounted 13mm G131s, replacing the MG-17s. Fw190A8, the A8 entered production in February 1944, powered either by the standard BMW 801D2 or the 801Q. The 801QTU, with the T signifying a Triebwerks Anlage unitized power plant installation, was a standard 801D with improved, thicker armor on the front annular cowling, which also incorporated the oil tank, upgraded from 6 ohm on earlier models to 10 ohm. Changes introduced in the Fw190A8 also included the C3 injection IHA paragraph HTE Notliestung emergency boost system to the fighter variant of the Fw190A, raising power to 1,980 PS for a short time. Fw190A8 per Rankine 2, the A8 per Rankine 2 replaced the outer wing 20 ohm cannon with a 30 ohm Mk108 cannon. Fw190A8 per Rankine 8, the A8 per Rankine 8 was similar to the A8 per Rankine 2, but fitted with heavy armor including 30 canopy and windscreen armor and 5 cockpit armor. FW-190A9, first built in September 1944, the FW-190A9 was fitted with a new BMW 801S rated at 2,000 PS. The more powerful 2,400 PS BMW 801 F1 was still under development, and not yet available. FW-190A10, late in the war, the A10 was fitted with larger wings for better maneuverability at higher altitudes, which could have allowed additional 30 caliber, long-barreled Mk103 cannon to be fitted. A total of 13,291 FW-190A model aircraft were produced. High-altitude developments. Tanks started looking at ways to address the altitude performance problem early in the program. In 1941, he proposed a number of versions featuring new power plants, and he suggested using turbochargers in place of superchargers. 3 such installations were outlined. FW-190V12, an AO, would be outfitted with many of the elements which eventually led to the B series. FW-190V13, WNR0036, first C-series prototype, FW-190V15, WNR0036, second C-series prototype, FW-190V16, WNR0036, third C-series prototype, FW-190V18, WNR0036, fourth C-series prototype, FW-190BO, with a turbocharged BMW 801, FW-190B1. This aircraft was similar to the BO, but had slightly different armament. In its initial layout, the B1 was to be fitted with 4 7.92 MG-17s and 2 20 MG-FFs. One was fitted with 2 MG-17s, 2 20 MG-151s and 2 20 MG-FFs. After the completion of WNR 811, no further FW-190B models were ordered. FW-190C, with a turbocharged Daimler-Benz DB603, the tail of the aircraft had to be lengthened in order to maintain the desired center of gravity. 4 additional prototypes based on the V18/U1 followed, V29, V30, V32 and V33. FW-190D. The FW-190D was intended as the high-altitude performance version of the A series. FW-190DO. The first DO prototype was completed in October 1942 with a supercharged Junkers Jumo 213 including a pressurized cockpit and other features making them more suitable for high-altitude work. FW-190D1, initial production, FW-190D2, initial production. FW-190D9, the D9 series was rarely used against heavy bomber raids, as the circumstances of the war in late 1944 meant that fighter versus fighter combat and ground attack missions took priority. FW-190D11, fitted with the uprated Jumo 213F series engine similar to the Jumo 213E used in the TAR-152H series but minus the intercooler. 230 Mk108 cannons were installed in the outer wings to complement the 20 Mg151s in the inboard positions. FW-190D12, similar to the D11, but featured the 30 Mk108 cannon in a motor cannon installation firing through the propeller hub. FW-190D13, the D13 would be fitted with a 20 Mg151/20 motor cannon. Ground attack versions. FW-190F. The FW-190F configuration was originally tested in the FW-190AO/U4, starting in May 1942, fitted with centerline and wing-mounted bomb racks. FW-190F1, early converted aircraft designated A4/U3, FW-190F2, renamed A5/U3S, of which 270 were built according to Focke-Wulf production logs and Ministry of Aviation acceptance reports. FW-190F2, based on the FW-190A5/U17, which was outfitted with a centerline mounted etc. 501 bomb rack, and in the FW-190 F3 per ranking 1, with 2 etc. 50 bomb racks under each wing. FW-190 F3, the F3 could carry a 66 imp gal drop tank. A total of 432 FW-190 F3s were built. FW-190 F4 to FW-190 F7, designations used for projects. FW-190 F8, the A8 model redesignated, having a slightly modified injector on the compressor which allowed for increased performance at lower altitudes for several minutes. Armament of the FW-190 F8 was two 20mm G151/20 cannon in the wing roots and two 13mm G131 machine guns above the engine. FW-190 F8/U1, long-range JA bow, fitted with underwing VMTT Schloerly shackles to hold two 300 OL fuel tanks. Etc. 503 bomb racks were also fitted, allowing the FW-190 F8/U1 to carry one SC-250 bomb under each wing and one SC-250 bomb on the centerline. FW-190 F8/U2, torpedo bomber was fitted with an etc. 503 bomb rack under each wing and a centerline mounted etc. 504. The U-2 was also equipped with a TSA-2A weapons sighting system that improved the U-2's ability to attack seaborne targets with a 1543 LBBT-700. FW-190 F8/U3, heavy torpedo bomber was outfitted with an etc. 502, which allowed it to carry one BT-1400 heavy torpedo. Owing to the size of the torpedo, the U-3's tail gear needed to be lengthened. The U-3 also was fitted with a 2000 PS BMW 801S engine, and the tail from the TAR-152. FW-190 F8/U4, created as a night fighter, was equipped with flame dampers on the exhaust and various electrical systems such as the Focke-101 radio altimeter, the PKS-12 automatic pilot, and the TSA-2A sighting system. Weapons fitted ranged from torpedoes to bombs. However, the U-4 was fitted with only two MG-151/20 cannon as fixed armament. FW-190 F9, based on the FW-190 A9, but with a new TAR-152 tail unit, a new bulged canopy is fitted to late-build A9s, and four etc. 50 or etc. 70 bomb racks under the wings. According to Ministry of Aviation acceptance reports, 147 F9s were built in January 1945, and perhaps several hundred more from February to May 1945. FW-190G, the FW-190G was built as a long-range attack aircraft. Following the success of the FW-190F as a Schlachtflugzeug, both the Luftwaffe and Focke-Wulf began investigating ways of extending the range of the FW-190F. Approximately 1,300 FW-190GS of all variants were new built. FW-190G1, the G1 was based on the A4/U8 JA bow rays. Initial testing found that if all but two wing root-mounted 20mm G151 cannons were removed, the FW-190G1 could carry a 250 kg or 500 kg bomb on the centerline and, via an etc. 250 rack, up to a 250 kg bomb under each wing. FW-190G2, the G2 was based on the FW-190 A5/U8 aircraft, similar to the G1. The underwing drop tank racks were replaced with the much simpler VMTT Schloerly fittings, to allow for a number of underwing configurations. FW-190G3, the G3 was based on A6 with all but the two wing root-mounted MG-151 cannons removed. The new VFW TRG bomb racks, however, allowed the G3 to simultaneously carry fuel tanks and bomb loads. FW-190G3 per ranking 1, the G3 per ranking 1 replaced the VFW TRG racks with WB-151/20 cannon pods, giving the G3 per ranking 1 a total of 6 20mm cannon. FW-190G3 per ranking 5, the G3 per ranking 5 was similar to the A1, but the VFW TRG racks were removed, and 2 etc. 50 racks per wing were added. FW190G8, the G8 was based on the FW190A8, using the same bubble canopy as the F8 and fitted with underwing etc. 503 racks that could carry either bombs or drop tanks. FW190G8 per Rankine 4, the G8 per Rankine 4 kit was a planned refit for the GM1 engine boost system, but never made it into production. FW190G8 per Rankine 5, the G8 per Rankine 5 kit replaced the etc. 503 racks with 2 etc. 50 or 71 racks. Trainer versions. FW190A5/U1, several old FW190A5s were converted by replacing the MW50 tank with a second cockpit. The canopy was modified, replaced with a new 3-section unit that opened to the side. The rear portion of the fuselage was closed off with sheet metal. FW190A8/U1, a similar conversion to the A5/U1. FW190S5, A5/U1 trainers redesignated. FW190S8, A8/U1 trainers redesignated. An estimated 58 FW190S5 and S8 models were converted or built. Combat history. The FW190 participated on every major combat front where the Luftwaffe operated after 1941, and did so with success in a variety of roles. Luftwaffe pilots who flew both the FW190 and the Bf-109 generally felt that, with the exception of high-altitude capability, the FW190 was superior. Production. A 0.40 km² Focke-Wulf plant east of Marienburg was bombed by the 8th Air Force on October 9, 1944. In addition, one of the most important subcontractors for the radial-engined FW190s was AGO Flugzeugwerk, which from 1941 through to the end of the war produced enough FW190s to earn it major attention from the USAAF, with the AGO plant in Eschurchleben being attacked at least 5 times during the war from 1943 onwards. Survivors and modern builds reproductions. Some 28 original FW190s are in museums or in the hands of private collectors around the world. In 1997, a German company, Flugwerk GmbH, began manufacturing new FW190 models as reproductions. By 2012 almost 20 had been produced, most flyable, a few as static display models, with airworthy examples usually powered by Chinese-manufactured Spitfire radial power plants, which have a displacement of 41.2 liters, close to the BMW 801's 41.8 liters. The nearly intact wreck of an FW190A5/U3 that had crashed in a Martian forest near St. Petersburg, Russia in 1943 was located in 1989. After restoration in Arizona, the FW190 flew again on December 1, 2010. Following the successful test flight, the aircraft was then trucked up to the Flying Heritage Collection, where it was reassembled in April 2011 and returned to airworthy condition. At least 5 surviving FW190A radial-engined aircraft are known to have been assigned to the Luftwaffe's JG5 wing in Herdla, Norway. More German fighter aircraft on display in museums in the 21st century have originated from this unit than from any other Axis Pausa Euro unregistered trademark military aviation unit of World War II. Operators, a Czechoslovakia, Czechoslovakian Air Force, a France, French Air Force. The French Air Force ordered 64 aircraft post-war from the SNCA Aircraft Company. The FW190A5 PRA-6 model that was chosen carried the designation NC900. The aircraft were used operationally for a short period and withdrawn due to problems with the BMW 801 engine. French Navy, a Nazi Germany, Luftwaffe, a Hungary, Royal Hungarian Air Force received a total of 72 FW190 F8 starting in the November 1944. They were operated by the 102 Vadis bomber ZA-cubed Zarzad, later 102 Xatarepula Paragraph Ostali engaging in close support missions on the Eastern Front in 1944 a Euro 45. A Japan, Japanese Army Air Force received one Fw-190A5 for evaluation purposes. A Spanish state, Spanish Air Force. The Spanish Air Force operated Fw-190A2, 3, 4 among Fw-190A8 and GS with volunteers of Escuadrilla Azul on the Eastern Front and defense of the Reich over Germany. A Romania, Royal Romanian Air Force, following the 23 August 1944 coup by King Michael, which resulted in Romania leaving the Axis powers, Romania captured 22 Luftwaffe Fw-190s and Fs. They were not used operationally. 9 serviceable Fw-190s were later confiscated by the Soviet Union. A Turkey, Turkish Air Force. The Turkish Air Force, beginning in mid-1942, received 72 examples of the Fw-190A3 from Germany to modernize their air force. These aircraft were basically Fw-190A3s, with BMW 801D2 engines and Focke-Wulf radios and an armament fit of 4 MG-17s, with the option of installing 2 MG-FFM cannon in the outer wing positions. The export order was completed between October 1942 and March 1943. The Fw-190 remained in service until 1948 to Euro 49. A United Kingdom. Royal Air Force, No. 1426 Flighter AF evaluated at least one captured Fw-190A4, a Yugoslavia, SFR Yugoslav Air Force, post-war, 1 aircraft. Specifications. Data from Fw-190A8, General Characteristics, Crew, 1, Length, 9.00 meters, Wingspan, 10.51 m, Height, 3.95 m, Wing Area, 18.30 mass squared, Empty weight, 3,200 kg, Loaded weight, 4,417 kg, Max takeoff weight, 4,900 kg, Power plant, 1 BMW 801D2 radial engine, 1,250 kilowatts, Performance, maximum speed, 656 km per hour at 19,420 ft, range 800 km, service ceiling, 11,410 m, rate of climb, 15 meters per second, wing loading, 241 kg mass squared, power mass, 0.29 to 0.33 kilowatts per kilogram, armament, guns, 2 13 unsynchronized MG-131 machine guns with 475 RPG, 4 20 MG-151/20E cannon with 250 RPG, synchronized in the wing roots and 140 RPG free-firing outboard in mid-wing mounts. Specifications. Data from General Characteristics, Crew, 1, Length, 10.20 meters, Wingspan, 10.50 m, Height, 3.35 m, Wing Area, 18.30 mass squared, Empty weight, 3,490 kg, Loaded weight, 4,270 kg, Max takeoff weight, 4,840 kg, Power plant, 1 Junkers Jumo 213A1 12-cylinder inverted V-piston engine, 1,287 kilowatts, 1,544 kilowatts with boost, performance, maximum speed, 685 km per hour at 6,600 m, 710 km per hour at 37,000 ft, range, 835 km, service ceiling, 12,000 m, rate of climb, 17 meters per second, wing loading, 233 kg mass squared, power mass, 0.30 a euro 0.35 kilowatts per kilogram, armament, guns, 2 13 MG-131 machine guns with 475 RPG, 2 20 MG-151 cannons with 250 RPG in the wing root. Bombs, 1 500 kg SC-500 bomb, see also, related development, Focke-Wulf Fw 152, aircraft of comparable role, configuration and era, IAR-80, Kawasaki Ki-100. Lavochkin La-5, Lavochkin La-7, Nakajima Ki-84, Polikarpov I-185, Republic P-47 Thunderbolt, Fort F-4 Ukasir, Grumman F-8F Barkat. Related lists, List of aircraft of World War II, References, Notes. Citations. Bibliography. External links, Warbird Ali FW-190 page, Digestschick der Focke-Wulf 190, List of preserved FW-190s around the world, Flugwerk FW-190. A German company building complete, flying FW-190s. U.S. evaluation of captured FW-190A4, the Flying Heritage Collection's FW-190A fires up its BMW 801 engine, the Flying Heritage Collection's FW-190D fires up its Dumo 213 engine, Modeler's Guide to Focke-Wulf FW-190 variants, radial engine versions Part I. Modeler's Guide to Focke-Wulf FW-190 variants, radial engine versions Part II.